China is set to launch a $657 million next-generation synchrotron near Beijing, which will become one of the few fourth-generation synchrotrons in the world. The high-energy photon source, HYPES, will rev up electrons to high energies and bend them around a circular track, emitting synchrotron radiation, mostly short-wavelength hard X-rays. These intense, laser-like X-rays will be siphoned off into 14 beamlines that scientists will use to image materials and biological structures at atomic to nanometer scales and take snapshots of chemical reactions over nanosecond time frames. The HYPES will allow scientists to study cellular machines, such as the protein-assembling ribosome, whole cells, and viruses at high resolution. The big challenge will be managing the huge data generated by these experiments. The IHEP team is now waiting on final review and an operating license from China's National Development and Reform Commission. After first light into the beamlines for a handful of in-house scientists in late December, the HYPES Users Committee will issue a call for experiments from the broader research community. Dong hopes the call can proceed by late January 2025. Competition for beam time is expected to be fierce, with only about 1 in 5 proposals making the cut at APS. HYPES is the first fourth-generation synchrotron in Asia and could be the next up for Japan's Spring 8 synchrotron, which plans to transform it into Spring 8-2 by 2029. The aim is to dial up Spring 8's brightness more than 100 times, making it the world's most powerful synchrotron. China has activated the most powerful advanced hypergravity machine ever built, known as the Centrifugal Hypergravity and Interdisciplinary Experiment Facility, CHIEF. The facility, based in Hangzhou, China, is capable of attaining forces that exceed Earth's natural surface gravity by thousands of times. It aims to advance scientists' understanding of various processes, from mountain formation to catastrophic infrastructure collapses. The CHIEF facility will provide a unique research platform catering to scientists working on some of the world's greatest modern engineering challenges, significantly advancing the field of hypergravity research. Hypergravity conditions are produced on Earth primarily to facilitate a testing environment for conditions humans may encounter during spaceflight, aerial combat, and other unique situations. The facility comprises a trio of hypergravity centrifuges accompanied by 18 on-board units, approved for construction 6 years ago by the Chinese National Development and Reform Commission, NDRC. Construction officially began in 2020. The preliminary completion of the project was hailed as a milestone in the field of hypergravity studies. The completed CHIEF centrifuge, expected to operate at a capacity of 1,900 GT, will significantly outperform the 1,200 GT capacity of the USACE's centrifuge, which up until now has been recognized as the most powerful centrifuge in the world. As one of China's 10 key scientific infrastructural projects according to the country's 13th five-year plan, the facility is estimated to have cost nearly $276.5 million, equaling more than 2 billion yuan.
Thanks for watching. Like for more.